Hi everyone, and welcome to the 17th video in the Weather Unlocked video series. This video will go over the different winter precipitation types and will give a brief overview on how we can forecast them. So the four typical types of precipitation in the winter are snow, sleet, freezing rain, and rain. So how can we know what specific type is going to reach the surface? Well, we can get a pretty good idea by looking at the thermal profiles or the temperatures on a skew-T diagram, otherwise known as a sounding. We'll be taking a deeper look at forecasting the individual precipitation types in the next few slides, but if you're not familiar with what a skew-T diagram is, make sure to check out one of our previous Weather Unlocked videos on our YouTube page that explains what a skew-T diagram is and goes into detail on what each component on the diagram represents. So we're going to break down each precipitation type individually, looking at what temperatures lead to the different types reaching the surface. And for reference, the blue background in this image represents temperatures at or below freezing, and the orange background shows when temperatures are above freezing. So first, looking at how we forecast snow at the surface, you'll notice that the background stays that blue color from the moment the snowflakes leave the cloud all the way down to the surface. And this shows that the air temperature remains at or below freezing for the entire vertical column of air. Now looking at what this looks like on a skew-T plot, if this black line represents our 0 degrees Celsius line, or our freezing line, you'll see that the temperatures in the entire vertical column of air remain on the left side of that line, meaning it's always below freezing. So typically when we see this, any precipitation that occurs will reach the surface as snow. Taking a look now at how we can forecast sleet, you'll see that the temperatures are at or below freezing when the snowflakes start falling from the clouds. But then those flakes enter into that orange background, meaning they enter into a warm layer with temperatures above freezing. This then causes those snowflakes to melt. However, you'll notice that those melted droplets then begin to fall into a deep cold layer with temperatures below freezing, which causes those droplets to freeze and form ice before reaching the surface. So taking a look at what this looks like on a skew-T diagram, again, if the black line is a 0 degrees Celsius, or the freezing line, temperatures in the upper part are to the left of the line, meaning they're below the freezing point, allowing for snowflakes to fall from the clouds. But as those snowflakes continue to fall towards the surface, they now enter into what we call a warm nose aloft, melting those snowflakes into rain droplets. But then those droplets continue to fall towards the surface and then reach a deep cold layer with temperatures below freezing again, causing them to refreeze and for sleet to reach the surface. Now, freezing rain starts out similarly to sleet in that temperatures are below freezing towards the top of the vertical column before falling into a warm layer. However, the main difference between the thermal profiles of sleet and freezing rain is that with freezing rain, there's a much deeper warm layer aloft, causing the snowflakes to melt into droplets. Those droplets do end up falling back into a cold layer with below freezing temperatures. However, it's a much shallower cold layer, which hinders those droplets from refreezing before reaching the surface. So instead, those water droplets become what's known as supercooled droplets, which allows them to freeze once they come in contact with the surface. Now the skew-T diagram looks similar to the one from sleet, except you can see how much deeper of a warm nose aloft there is, as well as a much shallower cold layer near the surface. And because there isn't enough time for those droplets to refreeze before reaching the surface, those supercooled droplets will freeze once they make contact with the surface and cause freezing rain. And then lastly, we have rain. So looking at this temperature profile, you can see that temperatures are below freezing towards the top of the vertical column of air, allowing for snowflakes to fall from the clouds. However, as they continue to fall, they reach an extensive warm layer with temperatures above freezing all the way down to the surface, which allows for those snowflakes to melt, forming into rain droplets. And you can see in the skew-T diagram that warm layer that extends to the surface, allowing for any precipitation that occurs to reach the surface in the form of rain. So that's how we as meteorologists differentiate between the different precipitation types in the winter. Now, an important thing to note is that forecasting precipitation types is not an exact science. There's a lot more that goes into forecasting winter precipitation, and there's always going to be exceptions. But this graphic is a good place to start when winter precipitation is heading our way. So that concludes this video on forecasting the different winter precipitation types, so make sure to stay tuned for future videos in the Weather Unlocked video series.